Look at question number 11. An object is placed at 2f of a convex lens. Draw the ray diagram showing the image formation. Write down the characteristics of the image. Look here. So here the principal axis is drawn, lens is drawn. Mark f and 2f. So while marking f and 2f, we should give the equal distances. Otherwise, cannot get the image. Look, I am being the equal distances. So while marking the f and 2f, you must leave the equal distances. Otherwise, you cannot get the image in the. So here f and what the distance left you from here to here? Same distance you have to leave from here to here also. F to f. Here f to f. So the question is the object is at 2f. When the object is at 2f, draw the object. Object. Look, a light rays from the object, the lens after refraction passing through the focus. After refraction passing through the focus. Yes. A ray of light is fall on the lens after refraction passes through the focus. And a light ray passing through the optics center passing without refraction. See, the position of the image is at 2f only. At 2f only, you are getting the position of the image. So, the object is at 2f, position of the image is at 2f, same size, inverted real image. So, when the object is at 2f, the position image is also at 2f, inverted, same size, real image. You are getting at 2f. This is question number 11a. So you draw the similar type of diagrams when the object is beyond 2f and the object is between f and 2f and object is between f and the lens. And on the object is at f, you are not getting the image. So the object is beyond 2f, object is at 2f, object is in between f and 2f. When the object is in between f and 2f, image is getting beyond 2f and enlarged image you will get. When the object is at 2f, the image is getting at 2f only same size. When the object is beyond 2f, the image is getting between f and 2f a diminished image you would get. But all are real inverted image you are getting in the convex lens. But when the object is between the f and lens, you are getting a virtual image on the same side, a enlarged magnified image you are getting at the same side of the object in a convex lens. And this is the concave lens, question number 14th A. Question number 14 A. The question is, in the figure, AB is an object placed on the principal axis of a lens L. The image formed by the lens is erect, diminished and worked image. It is concave lens. The image formed is by the lens is erect, diminished and virtual image is formed by the concave lens. Identify the lens indicated in the figure and draw the shape. So it is in concave lens. Question number A is you can say concave lens and draw the ray diagram of the image formation. Here also you mark F1 to F, mark F1 to F. F to F. The object is here. Where the object is a light ray falling on the lens from the object, a ray of light, and that diverge, not converging, it is diverging. And passing through the focus. And a ray of light passing through the optic center. So image is getting here. Erect image. Erect image, virtual image, diminished. So in a concave lens, erect image, erect, diminished, virtual image is formed by a concave lens. In the question number 14A, so question number 15, look. Question number 15. Question number 15. The object OB is placed between the focus and convex lens. The object OB is placed between the focus and the convex lens. Question A. If the height of the object is 3 centimeter and height of the image format is 9 centimeter, find the magnification. It's not 14A, 15. So, question number 14B. You can see objects magnifying using a magnifier lens, right? Question A. Where should an object is placed in front of a lens used as a magnifier to see an enlarged erect image? Draw the ray diagrams of the image formation. So if you want to see an enlarged erect image, you have to keep the object in between the focus and the lens here. In between the focus and lens, keep the object here in a convex lens. In a convex lens, the to get a enlarged erect image, magnified image, the object must be between F and lens. The ray of light After refraction, this is the virtual image you are formed by a convex lens. So when the object is between F and lens, you will get an enlarged magnified image, a virtual image. This is the question number B, 14, question number 14B. Look at the question number 13B. Observe the waveforms by P, Q and R given in the figure and answer the questions below. Question A. Which wave has higher frequency? Question 2. That's part 1 and part 2. Which wave has a longer wavelength? So the answer is in that figure. Question, which wave has higher frequency? The answer is R. R. And second question, which wave has a longer wavelength? That is P. The longer wavelength is P. Looking and understanding me. Then answer question B. The waves indicated in the figure take 0.1 second to travel a distance of 2 meter. If the wavelength of the wave Q is 0.2 meter, what is its frequency? The waves indicated in the figure takes 0.1 second to travel a distance of 2 meter. If the wavelength of Q is 0.2 meter, what is its frequency? So here time 0.1 seconds, time 0.1 seconds, and distance 2 meter. Distance is 2 meter. Time 1.1 second. Distance is 2 meter. So speed is equal to distance by time equal to 2 divided by 0.1, that is 20 meter per second. Speed is equal to 20 meter per second. Then lambda, that is wavelength. Lambda is equal to 0.2 meter. Wavelength lambda is equal to 0.2 meter. If the wavelength of wave is 0.1, what is the frequency? So we know V is equal to F lambda. V is equal to F lambda. So F they asked, F is equal to V by lambda. F is equal to V divided by lambda. V is 20, that is 20, and lambda is equal to 0.2. Wavelength is equal to 0.2, that is equal to 200 divided by 2, that is 100 hertz. 100 hertz. 15th question. 15th question. An object OB is placed between the focus and the convex lens. If the height of the object is 3 centimeter and the height of the image is formed is 9 centimeter, find the magnification of the image. So magnification M is equal to height of the image divided by height of the object. Height of the image divided by height of the object. Your height of the object is 3 centimeter. Height of the object is 3 centimeter. Height of the image is 9 centimeter. So we can write 9 divided by 3. 9 divided by 3, that is 3. An object OB is placed between focus and convex lens. If the height of the object is 3 centimeter and the height of the image is 9 centimeter, find the magnification of the image. So magnification you got 3, and can you project the image on a screen? Justify your answer. So question B. You cannot project this answer on a screen. It is because it is an virtual image. Virtual image cannot be caught on a screen. So that is the answer. Cannot. Can you project the image on a screen? Justify your answer. You cannot project the image on a screen because it is a virtual image.